Happy holidays, guys. My name is Pisek, or you can call me Ben12. I'm from Keston, and as usual, I plan to bring you insights and news about AI and generative AI so that you can bring that insight to improve yourself and your team. Today, we are in episode 19, and we have a lot to cover. So, today, we are going to talk about updates, major updates from Google, the Gemini team, and updates from OpenAI, obviously, by their 12 Days of Shipmas. And for the technical part of the episode today, we are going to deep a little bit deeper into what context length is for Ollama platform. And we are going to revise or revisit our YouTube summarizer, where we are going to dive into the LangChain load summarize chain again, and I'm going to present to you two methods to summarize long text, and then we are going to pack everything into the newly formed YouTube summarizer repo. So let's get started by subscribing to my channel. We are here on YouTube, but you can subscribe to my channel on Facebook, LinkedIn, X, and Substack, as well as on GitHub too. All right, the first topic is Gemini 2.0. So this is a summary after I explored Gemini 2.0 in my new series, the Random Forest series, still on this YouTube channel, but just a new series. So what is all about Gemini 2.0? You guys can come to my Substack and take a look at this post for a quick summary. And by the way, most of the text here are generated by AI, and I made a final touch. So pretty much Gemini 2.0 from Google and Google DeepMind team, they pivot this, or they position this to be a model for the new coming agentic era. And for most people out there, the agentic era is supposed to be 2025. So a few days, and we are entering the agentic era now. So with this models, Gemini 2.0, you can work with it via an Gemini Advanced, a ChatGPT version of Google. The Gemini 2.0 Flash is available for free. You don't need to pay the subscription to use the Gemini 2.0 Flash, but you can also use it via a Google AI Studio as well. And also the Gemini 2.0 Flash is going to be available for the API call too. All right, all in all, Gemini 2.0 is a much upgraded version of the Gemini 1.5 Pro. The models will receive multi-modal inputs, meaning that the inputs can be in a form of text and or images and or voice. So yeah, you can input in many forms to the model, and that's old news, right? The Gemini 1.5 Pro is like that too. But the 2.0 version, the output is also multimodal, meaning it can output both text, images, and eventually audio at the same time. So the model is trained intrinsically or natively multimodal, both inputs and outputs. And because now the model are trained to use tools better or reasoning better, it can be done. It can be a good agent. So yeah, tool use is native, audio is native, image generation is native as well. Now, Gemini 2.0 announcements also showcased 3 projects that they are working on, and when this is done, it's supposed to give a huge boost in the Gemini 2.0 or maybe a later version of Gemini's. One of the project is Project Astra. I think a lot of people, or some people actually, are experimenting with this. So basically, the model will take in inputs in many forms, text, voice, videos, and it would just respond back to a user like this. And I think you need to use a Pixel phones or some kind of like Android OS in order to be a trusted testers for this. So yeah, multimodal understanding from text, videos, images, and voice. And also multilingual, like in this video, if you go to like Google announcements and you see this video, the lady in the video will speak French and the model will understand. And this model is experimenting in Google AR smart glasses. I think you have seen the AR announcements as well. But all in all, this is the experimental project to improve the Gemini 2.0 multimodal ability, reasoning ability, and to usability. The next project is the project Mariner. Basically, it's an AI agent specifically trained it to help human in any task related to web browser. Like this one, if you look in this in the video, it's going to help a user process Google Sheet, but it's representing itself on a side panel. But because it understands the web browser or even like the cap screen, it will understand how it should do the task assigned to it. The last one, this is what I'm actually going to touch a little bit upon today, is the deep research. So deep research, even though it actually relies on Gemini 1.5 Pro, when we see later on, but it actually a experimental project aims to ask AI to do a thorough research on a particular topic. So eventually, if this is successful, it's going to help you reduce the amount of time you need to spend researching something on the internet, and it's going to write a report for you. So you are going to have a step to read the report and do the final crafting. All right. So yeah, pretty much better in multi-modal ability, know reasoning well, natively producing images and audio, know how to use tools really well, and pretty much now it has an ability to respond in real time as well. But I haven't tested that yet. I think I did actually in Google AI Vertex Studio. You can actually take a look at that, and if I recall correctly, when it was responding to me and I interrupted it, I need to wait for like 2 to 3 seconds. So it's not really real time yet, but 2 or 3 seconds, they will plan to reduce it to milliseconds, I think, in the future. All right. So yeah, all in all, right now the Gemini 2.0 version, at least one of them is out there. It's a Flash version, and you can access it for free using the Gemini webpage here. Even though I have signed up for the advanced version because I would like to experiment or try the deep search. The 2.0 Flash experimental is available, is in preview mode, but it's available for free user as well. So you don't need to sign up. So having said that, I want to show you deep research. So pretty much what you can do with deep research is you can ask the AI, the model, to do research on any particular topic. So let's actually show you the exact same prompt that I have done before and show you that so you can see what is happening. So I am going to ask the 1.5 Pro Gemini deep research mode that I want to research. I want you to write the research for me on 12 days of OpenAI. Recently OpenAI has a 12-day campaign. They just keep announcing things and steal spotlights from everyone else. So this is the prompt that I will give it to Gemini Advanced 1.5 Pro in the deep research mode. I hit enter and it's thinking a little bit, and what you see that it's going to give you a plan. Here's a plan I've put together. Let me know if you need any changes before I start researching. research website. In the past few weeks, there is a series of announcements from OpenAI. I think it's like 12 days of OpenAI. Research that for me. Find the latest announcements from OpenAI in the past few weeks, compile all announcements into a list. For each announcement, find deeper details. For each announcement, find out. There's so many more in here. Anyway, so there are two buttons that you can click. Start research or edit the plan. I will try edit the plan first here. So I kind of like cheated a little bit, so I know what I need to search for information. So I would say there are good references in YouTube that OpenAI posted themselves. You must use, you should actually, I'm not sure if must is too strong, should use those relevant YouTube videos as primary sources. If I do that, I'm not sure what is going to happen. I think it's going to revise its plan. Let's see where the revision takes place. Here we go. Find latest announcements. Compiles all announcements to list. Each announcement find deeper. Find out the community thinks. Call out new features. Here we go. Find relevant YouTube videos posted themselves. I think I need to revise that again. Okay. You should use YouTube video early on in your plan. Let's move that to step 3. Okay, let's see how it's going to be. All right, hopefully it can revise its plan according to my instruction. Is it done yet? It's not done. But yeah, relevant YouTube video is now at step 3. And I think let's just go with it right now, and you can click start research. What is going to happen is that Gemini, that's embarrassing. Gemini 1.5 Pro is going to search. It's coming up with a list of URLs. It needs to do research, and it's going to go through that. Not sure it's actually doing YouTube video, but let's take a look. Come back and take a look at this later. But like fast forward to a similar prompt, but I didn't adjust any plan. So what happened is that I click started research, and it's going to do its thing. Here starting research, compile this, and eventually it's going to write a report of that research topic. And this is one of them. OpenAI's 12 Days of OpenAI, a flurry of innovation. And this is actually what it has found information on the internet and summarizes it into a graph, into an article. But now what I want to emphasize is you should look into websites that it grounded its information from. Look at that. You need to look at its credibility, like independent.co.uk. Is it a credible source you should credit to? This looks okay to me. What is this? Hindustan Time. I don't know what that is, but not sure. This is not like the first rate source, right? Maybe like secondary source. But yeah, like OpenAI thing, it should be okay. This is not really relevant at all, I think, but somehow it's there. So once you know that what references Gemini 1.5 Pro used to create a summary, you will actually know the whether you should trust it or not. Okay. So if I click this one, it's going to open a Google Doc for me, and this is what it looks like, the whole article in here. And as you can see, this is not what I wanted. I just want what is day 1's announcement, what is day 2's announcement. So this is not what I want at all. So yeah, for some reason, maybe my prompt is not good enough to guide it in the way that I want it. But again, if it's going to be just a general research topic, maybe not on the very recent developments yet, maybe you want to research how much would it cost to implement a on-prem server to host the LLM, maybe that works, because might not be that like cutting edge information, but you know, it's going to be useful at some point. All right. And this is it for Gemini Advanced Deep Research. I think if you do a lot of internet search, it's worth spending for the subscription. Okay. The next section, next thing that I want to talk about is the data science agent from Google as well. It's an experimental project that I think they came up with an agentic system. I'm not sure it's 1 or 2 AI or more, or multi-agent, but this agentic system will break down the task of data science into steps and execute it for us. So you can land on this page via this one, labs.google.com/code. And this is in experimental mode. And if you don't live in a particular region of the world, this might not work. So if I go check it out, you can find more instruction here. So yeah, so if you click playground, and assuming that you are located in the right part of the world, this should work. So let's actually try. Access denied. Thank you. Let me refresh this again. Here we go. I kind of like sneaked around a little bit, and I get myself to be virtually where I'm supposed to be using this. All right, new projects. On the right hand side, you have your previously done project. So let me just delete that too. So we are going to do the Titanic dataset again. So I will upload a file in the demo files right here. I have this dataset. All right, Titanic dataset. It's a popular dataset on Kaggle. This problem has probably been solved millions of times, and the AI may already memorize all the tricks there and do it here, but that's not the point. I want to show you how this is project is formed, and if it's successful, then it's going to help a lot of people out there who don't have data science skill, or even expert data scientists save a lot of time in doing basic stuff. All right, what would you like to learn from the data? It could be simple as show me insights or tell me about the data set. Instructions. 1. Explore. Perform basic EDA and data processing or cleaning, then perform basic correlation statistics and plot with heat map. All right. Okay, and let me just ask a little, add more context. This data set is should be trained for a model that will classify if a passenger is likely to survive or not. All right, and then perform basic ML model training and evaluations using Psi. I'm not going to say anything. Let's just throw it out there and see what they are going to do, what the AI system is going to do. Compared many types of models. I think even though you can leave typos there, but I prefer to clean up my typos. Compare many types of models, including random forest, SVM, and SVM. And for each model type, do what is the word? Hyperparameter search. Hyperparameter search. Maybe grid search. All right, I actually put a lot of data science knowledge in there, but the point is you can be as detailed as you want, or you might want to leave it a little bit open. Okay, let's say that I'm happy with my prompt. There is only one thing that I need to do is to click this continue button. And if everything is right, it's now again planning what it's going to do. I'm not sure if the model behind this project is Gemini 1.5 Pro or Gemini 2.0 Flash. I don't know, but it actually works, right? So the plan is to data load, data explore, data clean, data wrangling, data analysis, visualization, splitting. Yeah, that's preparing for training now. Feature engineering, create new features or select features, combination of features. Now, model train, model optimize, evaluate, and final task. Wow, that's a lot of planning. All right. It's not doing anything yet. So the plan looks good. Yeah, I think it's fine now. You can edit the plan, but I'm just going to leave it there. And I can click create collab. What is happening here is, it has some scripts to create notebook, Jupyter notebook in Colab and execute codes. And eventually you are going to get a fully functional and already run Colab exported to your Google Drive. And this is cool, and it's probably going to take like 1 or 2 minutes for it to finish. And in my experiment, I tried with a ChatGPT, giving it the same prompt and the same data set. It kind of do things similarly, not entirely identical, but on the same path. So I am pretty happy with this, and I can't wait for it to be actually launched, because we have a lot of machine learning projects and data science project to do, and this is actually helping us not spending time writing exploratory work, because like typing in all this, it would take time. But right now what we can do is just ask it to do most of the tasks for us. All right, that's actually pretty much it for Google, but maybe we'll come back later to revisit this. But for now, let's go to the second topic. OpenAI has announced for 12 days in a row about so many things, and that's what we are going to talk about. Maybe I am a person 1 million that are talking about this, but anyway, so just to educate people who have missed, or just yeah, for the sake of completeness. All right, so I have summarized everything in a Substack post. Oh, the trick is I am too lazy, so I asked ChatGPT to summarize itself. Right, that's what I did. Okay, I am going to go to my web page. Here we go. A quick summary of all announcements from the 12 Days of Shipments by OpenAI, where the summary is crafted by me and ChatGPT with little manuals on images and link. So OpenAI has released O1 model officially, not in preview anymore. It's going to be in the subscription versions, either a plus or a pro. A pro is $200 a month. Some people say it's worth it, but for me, not there yet. The performance of O1 is crazy good. Look at that, like math competition level. It's much better than the GPT-4o by almost 7 or 6 or 7 times for accuracy. Coding is also pretty good as well. And science, like competing there, even better than human experts, So basically, the O1 model is awesome. And the reason behind it is an internal chain of thoughts thing. And you will notice that you take like at least around like 30 seconds before it will start answering to your prompt. But that's why, because it's implementing its own reasoning internally, it's getting the performance really, really good. Reinforcement, fine-tuning, research. So OpenAI is experimenting with a new type of fine-tuning because if you use like OpenAI platform, kind of like a platform, you have tools to actually fine-tune your model, but they are experimenting with the reinforcement version of that. So right now it's in preview, only inviting researchers, university, and enterprise to participate. I'm not going to be related to most users like myself, but it's out there. Now, the thing that I'm curious and excited is Sora. Eventually is out for real, and it's amazing. And you can actually access it via Sora.com, which is going to be the next topic after this. So let's move on quickly, finishing this. Canvas now, it's out of the preview mode. It has its own place in the ChatGPT interface now. But I really use it a lot when I edit. I need a lot of editing rounds, like writing documents or writing codes. It's actually very, very useful. ChatGPT is in Apple Intelligence, so it's kind of like integrated better. You can ask Siri to ask ChatGPT directly, but this is something that I don't want to talk about more. Advanced voice, I don't use that much, so I'm just going to skip it. Projects in ChatGPT. Project is like, it provides a scope of context. Context can be now files. You can upload files into a project. It can be chat sessions related to that project. So basically, projects is mechanics for providing a boundary of context so that you can shape something better than needing to upload information via the upload button so many times. So yeah, this is like reincarnation or copy of what Anthropic has done way earlier, right? But again, it's useful, I think. And if you look, you actually watch this video, one of the guys in there was showing how he redo his website using this project feature. So it's kind of useful. I haven't used it myself. I plan to do so in the future. ChatGPT search, yeah, you can search, right? Holiday treats, sure. Basically, O1 model is now available not only with the user interface but also in API as well. So that actually got me asking O1 API cost. I don't know how much cost it is. Pricing. Let's see. Latest models. So here we go. GPT-4o. Quite cheap now, $2.5 for input, 10 for output, 2.5 and 10. Where's the O1? Come on. Look at that. 15 and 60. 2.5 versus 15 and 10 versus 60. 6 times. Yeah, that's the cost that it takes when the model is getting much better. Why did I say it twice? That's weird. Anyway, day 10 on the phone. I can't care less. Work with apps, so it's going to be integrating better on the desktop. That's what I see. So a guy was asking
code automatically paired to it. Xcode.
So he's editing something with Xcode, and there is a desktop ChatGPT version helping him. So pretty much it's integrating better. It's going to be useful if you actually tried it, I think. I haven't yet. And for the last day, it's a preview of O3 coming. O3 is supposed to be much better than O1, and we are so excited to have our hands on the preview, and hopefully it's there yet. Anyway, what I actually want to talk a little bit more deeper is day 3, Sora. So Sora is available via Sora.com. You can then sign in with the same account that you have with the ChatGPT Plus version. Sora is available for the paid subscription, like the ChatGPT Plus. The Plus and the Pro version will have different limits, of course. For the Plus version, like I cannot generate 1080p version, which I'm fine. I'm not going to be generating a lot of videos just yet. And there is a section where you can explore what. Oh, okay. All right, I need to verify myself. Successful. Here we go. That's a section of explore where you can take a look at what videos have been generated by other people. Like, oh, this guy. Oh, look at that. This is actually a good video, so I can save it for later. You can actually see a lot of creativity out there, and maybe this can be good for a company trying to be a good consulting company. And I don't know what this is. This is weird. Yeah, trans configuration right there. Oh my god. Okay, that's pretty. Oh, okay. Yeah, if you're curious how to prompt something like this, just go and click, and you might be able to see the prompt. Where's my bridal brown and black greyhound? Okay, that's a prompt to make this. Interesting. Am I missing anything? Why does it look so easy? Oh, that's cute. Look at that. Wait, can I see a prompt? I don't see a prompt. Hedgehog holiday cheer. So that's a prompt, I think. Okay. If you saved anything, you can come to the saved version, and you can have your own like collection of inspiration. I think like this guy. I think this is cute. Chibi vase dance. Look at that. That's how cute this is. Just 3 words, and you got this. I saved this video because it looks real, but look at that. Vob. Something just popped out of thin water. Right there. Yep, that's hallucination. Physics is not implemented in here, but you know, it's fine. Okay, now if you want to create yourself a good video, just describe a video and set to whatever configurations or settings you want, and you can click this one to generate. There is another feature that I haven't explored yet, which is storyboard. Apparently you can describe each scene and it's going to compose according to what you described in each of the scene. Give it a try. I haven't tried yet because one video takes a long time to generate. I tried this one, anthropomorphized green parrot in Christmas weather. It's longer than that, but yeah, maybe I need to do this. Yeah, playing saxophone near shiny decorated Christmas tree with several presents, and this is what I got: a strangely looking parrot. And this is like 480p, and took about like 5 to 10 minutes to actually generate this. Not bad. It's for fun, I think. So looking forward to better Sora model in the future. Okay, that's pretty much it for the update from OpenAI today. But before we actually go to next technical topic, let me just revisit the Gemini data science guy. So all the steps have been done, right? Look at that. Planning, do some data loading. Data load, it had some code and load itself. Exploration, blah, 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 until even like model training. It used scikit-learn, doing something there. Optimization, you know, like, okay, this is cool. Grid search. One thing is, there is no reason of why these numbers are there. So this is just template for you to fix. But unfortunately, without any intervention, it ran everything to the end and gave me a result. Best performance model is a random forest right there. It has some summary as well, like why are the SVM prediction all zero, like insights, generating insights from what is found or encountered in its code run. Yeah, and now you can download a notebook or open it in Colab. And this is it. You are going to get a template. What is happening? Right, now export notebook to Drive. I can open it, and as I mentioned, some numbers are not optimal, but it serves as a really good template for you to get started with data science project. Yeah, here we go. Everything is in here, right? Even plots. Look at that. Plots are there. The report, what it thought of, is already there. So it's just really good starting point for human to now come in and edit the code. And it's going to be much easier if you use code assistants, AI like Jules from Google. I'm not sure if it's released for general public yet, but that's the name, or Copilot, or any other AI. All right, the second half is going to be technical. We are going to start with context length in Ollama. In Ollama. So what is context length? Context length have many forms, right? The first one is the LLM's context length itself. This is the context length that the model is trained on. Beyond that, it's going to get worse. For example, like Llama 3.2 has a context length of around 128,000 tokens. GPT-4o is roughly the same thing. Gemini 2 Flash or 1.5 Pro, the context length is 1 million tokens. But what I want you to think of it is, this is the maximum number of tokens the model can make sense of. Text or token series longer than this, it's going to lose its mind. It's going to make mistakes because it just overflow out of this. All right. Now, when we are implementing LLM with Ollama, Ollama has a context length or context window as well, and this is controlled by an argument called norm_ctx or context, and the default value is 2048. If you don't know this, then you are actually limiting yourself to this number, and you are going to run into many problems. That I will show one problem right in this section. So if you want Ollama to summarize a text and you have this small context window, what can happen is that the context input text can be larger. But anyway, whatever you do in Ollama has to be within this Ollama setting context window. If your input text is really long, then your summary would get like squashed out too. So basically, these are all the lengths of the tokens, token lengths that you need to think about. The first one, to recap, is the ultimate token length, limited by the model's intrinsic ability to know itself. Now you are implementing Ollama. You have a knob to tune it, to set a context window to your liking, to suit your application, and you need to do that. All right. You need to be taking care of how long is your input tokens, and how long you want the summary or the response from the Ollama to be generated. And this number is actually controlled by norm_pred, the number of predictions, and the default is 128 tokens only, or maybe 256, maybe I'm wrong here. But again, this value is fixed, and if you don't know, then you are capped, you are limiting yourself to many possibilities. Okay? So the challenges, as I mentioned, is if you're talking about providing prompt to the LLM via the Ollama layer, maybe your prompt is too long. You are facing with long input text. In our today's sessions, we are going to talk about summarizing a text, and one of the application here is summarizing a very long text. Let's say the text is 4,000 tokens long, and if your Ollama setting is only set to 2,000, then how are we going to handle that, right? We are running into a long input text problem. On the other hand, if you don't set the num predict properly, then your summary get cut off. If you want the model, let's say, to summarize input text in detail, and detail can means like 300 tokens in the summary, but you cap yourself, you don't know that, you cap yourself to 128, then your summary is going to get chopped, right? Summary cutoff is a problem when you don't set the num predict properly. So let me actually show you with this problem in coding demo. So this is available on my GitHub repo, Ollama nuggets. I plan to add more nuggets in this repo, but the first nugget is about the context length. So let me bring up the Visual Studio Code for this. All right. So yeah, I started using Copilot, GitHub Copilot, because it's free and it's quite useful so far. Anyway, so let me bring your attention to this. So let me clear everything. All right, so this notebook, it's only one in this subfolder called context length. This notebook is going to go through steps to show you the problem that we'll face if we don't set the context lengths, the num underscore ctx or numpred properly. So we are going to load up LangChain stuff like Ollama, tokenizer, and everything else. This is not used, but anyway. I prepared a sample text in the file here, and it's actually consists of about 200,000 character in it. So for the first 500 characters is like this. This is a transcript from a YouTube video featuring Andre Kapathy 3 years ago. It's an interview like with a moderator, not a moderator, a host and Andre. It happened for 3 hours. Like the guys were talking for 3 hours non-stop, and this resulted in this long conversation. And if I want to summarize this, I am going to run into the long input text problem. But anyway, so let's focus on what we have now. I have two helper functions. The first one is to split the long text into chunks. We are going to cover this in the next topic, but for now, I have text splitter split into smaller chunk, and I have a function that can count how many tokens in a given text, and this is what we are going to use most of the time here. So I am going to just pick the first 50,000 character or letters from the actual transcript, and I'm going to divide the chunk. Actually, let me just introduce chunks. All right. If the input text is too long, one of the ways to handle that is to chop it into chunks. And the way to do that is, let's say we want to have a chunk of 10,000 tokens, or the chunk should have around like 10,000 tokens. We'll do that. We'll have a method to chop the chunk, chop the text into chunk, and the function that we are going to do is this guy. This guy will take chunk size, how many tokens in a chunk should have, and overlap size. It means how many tokens that the first chunk and the follower chunk should have. So this is the overlap size. Okay, and I'm using the recursive character text splitter from LangChain library to help me do that. Okay, so let me set the chunk size to 2,500 tokens. This is in tokens, no overlap. So what this is going to do here is to prepare a document. This is just a procedure. You have a text, you prepare document objects, and you create your text splitter, and then you use your text splitter to split the document into split docs. And when I run this, you are going to see that I have 4 split documents or 4 chunks. Why? Well, roughly we have this is characters, by the way. This is not token. This is letters, not tokens. It's quite misleading, right? Because 50,000 divided by 2,500 is not 4. It's misleading, but you can come and see here. There are 4 split chunks, right? The character in each chunks are like this. Roughly the same, but 12,000-ish, but not 2,500. That's characters or letters, right? But if you count tokens, it's roughly 2,500 as I specified. In total, the whole thing, the whole chunk, the whole text here has got about 9,000 tokens. Anyway, I have a large text. I split it into chunks. Each chunk is about 2,500 in tokens. Now, I am going to define my model. I'm going to use Llama 3.2. Using Ollama here, a temperature 0.5, and the number of the context length of Ollama, right? Remember, it's this length. This is length. This length is right now it's around 1,000. But if you recall, the chunk itself, forgetting about this, the whole chunk itself is 2,000. So it's overflowing, right? It's long, larger. Okay, I will execute this. Now I have my model ready. This is the template. This template will say, write a detailed summary of the text section in the bullet point. And I provide the text in chunk here. So this is a kind of like a prompt template. And then I will fill in the information in the placeholder like this with the first document, the first chunk, in this manner. And I will print out to you what it is. All right, I run this. I am printing full prompt, but before that, you can see that now the full prompt has around 2,500 tokens. And this is actually the whole prompt. Write a detailed summary of this text section in bullet point, blah, blah, blah. Know the text. And this is the actual chunk from the original text stuffed into a prompt template. And the prompt template ends with summary according to what I have here. So pretty much this is a prompt template that I will now put into AI or the LLM, and it will ask it to summarize for me, right? This is case number one. I'm showing you overflowing. This is a case where the Ollama context length, this guy, is only 1,000, but the whole input text, the prompt, the full prompt in this case, is 2,500. All right. What I want to show you here is also you can see the symptom from Ollama. Okay, now I'm serving Ollama for running. So if I execute this, it's going to send a full prompt, this one, to the LLM. The LLM would then generate response from me, now called output. So let me just do that. Here we go. You will see some activities in this page. Right, okay. Here, the LLM is, sorry, I think it's finished. All right. So look at that. This is Ollama warning us to truncate input. Sorry. Oops. Oh, where was I? So I missed my point. Let me just. This is not right. Let me actually see this. Okay, the context length is set context length to 1,024. All right, let me try it again. This is weird. Okay. Now let me execute. Oops, what did I just do? Let me just execute this guy again and run this. Now I'm running this guy. All right, here. This is what I want you to focus on. So it's kind of like be pushed down a little bit. Now I need to find it. Where is it? Not here. Here we go. this is something that you might have missed here. So again, in this case, the Ollama context length is only 1024, but our prompt is roughly 2500. Okay, so it's hidden in a warning that your input prompt is being truncated, right? So this is going to be a problem. You are not going to get full performance because your prompt is being truncated. So basically, it might be only seeing the first part of the prompt, the first 1024 tokens, and this is what it has generated. Okay, that's a problem. Then another symptom that you see here is it doesn't look like it has finished its sentence too, but that's the prompt for later. All right, now we are going to move to a case where everything, the prompt here or the input text is within Ollama context length. So before I do that, let me just clear everything here and Ollama serve again. I am going to triple the context length of Ollama from 1000-ish to 3000-ish, and everything else remain the same. So I am going to run this code now. Okay. All right. And oh, I also run that as well. So if you go up a little bit, you are not going to see warnings of being truncated. Yeah, you don't have it there. Okay, so this is fine. It means that you increase or enlarge your context length of Ollama to support the input text that you need to process. Okay, but again, for this case, you still see that this doesn't seem like it's a complete sentence. If it's a complete sentence, it should have a full stop. So we need to solve that problem too. Okay, I'm not going to run this code. There's no point now. All right, so let me just, what I'm going to do here is I keep everything else the same as above, meaning context length is around 3000, but I am going to increase the number of prediction. Okay, something to notice is that the context length is 3000, right? The number of prediction is 1000. So in total, if we come back to this page, this is around this length, input length is around 2.5 thousand, and this is 1000. So this maximum is 1000. So now it's like 3.5 thousand tokens, right? So that's, it's risky. That is this enough? You might want to put some buffer, let's say to 5,000. Yeah, just to be safe, I will just bump it to 5,000. Okay, and I will run this. Run again. Okay, right now what is happening is now it's executing and it has finished, and we'll take a look at the, by the way, there is no warning. Here we go. There is no warning in this section. It's fine. And if you take a look at the last part of the output, it looks like it's finished itself. So with this setting, like 5,000-ish context length of Ollama, you have room for the model to answer. Okay, so how does it compare with GPT-4o Mini? So I took a liberty to put in code that will create a model that will communicate with OpenAI server, and we will use GPT-4o Mini. I want to use 4.0 mini because kind of like, I'm not going to use 4.0 because we are using Llama 3.23 billion parameter model. So it's smaller model. So I want to have downsize it to the smallest I can find. Right now it's like a 4.0 mini. So I would just use that. I give it the same full prompt and I'll get the response back. Here we go. And this is the response from OpenAI GPT 4.0 mini. It's a little bit longer. Visually, it's not like really rigor. So in this chunk of code, I just ran that chunk of code to actually see how these guys are compared. So the GPT 4.0 mini, the output seems about twice longer compared to what Ollama has produced, and this can be because of my prompt, right? Notice that this AI, this model GPT 4.0 mini, can be smarter, and it might have an inherent system prompt that asks it to do detailed summary. And you know, it's a bigger model and it knows a lot more. Look at that, it has corrected Kapathy, the name. Look at this guy. This guy got the name spelling wrong because it doesn't really know much, right? This guy knows a lot, so it's supposed to be much better. Okay, the longer the better is not true. Personally, I try to maximize the use of the context length, but then the result can, not suboptimal, can be not entirely related to the context length. For example, in this case, in this situation, I increase this context length to like what, 10 100,000, so as close to the limit of Llama 3.2, and also I put the number of predict to -2. -2 means fill in the context length, and the result is not much different. It looks like it's stuck. It doesn't get much better than this because of the model's knowledge or something like that. Even worse, it took me 10 minutes to actually get this output. So all in all, well, by the way, 10 minutes on the M4 Pro MacBook. All in all, this parameter is open for optimizing. Again, the parameter, I mean the number of context length, is open for optimizing if you want to implement it in your own application. The longer doesn't mean it's always better. Now, you have seen that if the num predict is set to a low value, it's likely that the model will get stopped before it's finished its response. So I want to explore the numbers here. So I have values from small to large. -1 means just keep rambling your answer. -2 means stop at your context length. So I have it in a loop, and let me just iterate it out, and you can see that Ollama is running. It's generating like, you know, 3 or 4 seconds per round here. And in a few seconds, we should be able to show the result. Okay. 1, 2, how many now? I think we're getting there. All right. So we have collected all the outputs here, and oh, why am I doing it again? Because I am silly. Need to run it again, guys. Let me just do this one. I changed my method a little bit. Previously, I was using completion version, chat completion version of Ollama, but now I'm using a chat version. Slight difference. You just need to get a content. Anyway, so that's for another talk maybe. So I'm just going to run the loop of numpredicts again, and oh, not numpred, sorry guys, it's gotta be numpredicts. Okay. All right, so the first one is 128 tokens long, and the same thing happened. The answer or the response didn't get fully finished yet. Output number one is when I have 256 tokens not finished with the full stop. Output 3, hey, looks like it's okay now. Output 4, that's fine, okay. Now if I put everything in a Panda data frame, I can compare better. So yes, with the loops that we just went over, it looks like I might want to this is the number of prediction that we specified, and this is the actual number of tokens. It's getting close. Somehow it got truncated before it's actually finished. Not here. When we look at it, oh sorry, I was wrong. So yeah, this guy is right. Sorry, output 1, 256 tokens. Output 2, 512 tokens. Somehow it got chopped. This can be the model's mistake. I think the model just say stop, and yeah, that is weird, very strange. Right, so if I'm going to say maybe this is 256 could be enough for this prompt. If I run again, this might change, this might be okay, but all in all, like for this prompt, why am I saying this prompt? For this prompt, because we are testing only this prompt, okay? For this prompt, seems like numPredict at 256 is okay. But if you change your prompt, let's say write the detailed summary of blah 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 text section in 10 to 20 bullet points, I bet it's going to take much longer than 256 tokens. So this loop depends on your prompt. Okay, the optimal point depends on the prompt as well. All right. Yeah, I think this is pretty much about the context length. Just to summarize everything, first you have the ultimate context length limited by the model itself, and usually right now around like the end of 2024, 128,000 token length, context length is common. But don't forget to adjust your context length in Ollama setting, and that's when you define your model like this. You use a numCTX to do that, and also you need to play with a parameter numPredict in order to set how many tokens the model should, the maximum number of tokens that the model would just stop generating. Okay, this is, by the way, just to emphasize again, the number of prediction you specify here is the maximum possible tokens that the model would generate as a response. It doesn't mean that if you put numPredict to be 1024 tokens, the model will fill in 1024. No, it can stop anytime before hitting the number of prediction limit. Okay, that is about context length. Okay, why we are talking about it today is because it's going to be related to one of the application of generative AI or LangChain wrapper is about text summarization. I talked about this in my free webinar several weeks ago, and it was embarrassing because when I give my code a really long context length, it failed. It gave out an error. This is because I wasn't configured the context length properly. And let me fix this with this episode. All right. Summarization task. What you are going to encounter is a challenge of input text too long. What we can solve, or we can remedy this situation, is by splitting the long input text into chunks before summarizing it. There are two approaches that we can do. The first one is what we call the map reduce method. In the map reduce method, we are going to process all the chunks to get a summary for them respectively first, like this. Chunk number 1 got summarized to summary 1, chunk number 2 to summary 2, and so on. And then in the next phase, in the reduce step, we are going to say reduce all these summaries into a final sum. Right? That's it. So this method, map reduce method, involves two major steps. The first one is the map step. You map a chunk to a summary. And in the second step, the reduce step, you stack up, you ask the model to merge or create a final summary out of all of these summaries. And the way I stack them up horizontally is for you to see that the more chunks you have, the longer this input length to the LLM will be. That's another challenge. You might cut your chunk into 10,000 tokens. Sorry, you might cut your chunk into let's say 1,000 token. If this is 1,000, right, and somehow your summary is 200 tokens, and you have to stack them up, and maybe the reduce is maybe another 200 token, and then when you stack them up, now it becomes long. It can be long, right? Let's imagine if this is 3,000, and then now 4 of them give you 1,200 tokens already. So the more chunks you have, the longer the reduce step prompt will be. And this can got you back into a long input text problem again. All right. So this is the map reduce method. Now the second method is a refined method. What we do here, still, we are going to break the original long text into chunks. But there are two phases here. Phase number 1 is the initialization phase. We take chunk number 1, get a summary, right? And then we set up a variable called existing summary and give the summary to that variable, this one. In the second phase, we are going to do iteratively or until we finish last chunk. So for the next chunk, we compute the summary, and then we ask refine. You give an existing summary and a new summary. Refine it to be a new existing summary. So, and this will keep repeating until you have completed all the chunks. And this is a refined method. What you need to notice is that there is no way to speed it up. You have to do chunk by chunk because it has to be done in sequence. While if you go back to take a look at map reduce, this process can be done in parallel. So typically, if you have code that can parallelize the processes, This method, map reduce, is going to be faster because it can map in parallel. However, the benefit of the refined method is because you are doing this in sequence, then it will flow, it will have a better flow. That's what I can say. It can summarize things as it goes on. But you know, maybe if the model is smart enough, let's say GPT-4 or Mini, it might be able to correlate this in time temporal correlation as well, right? All right, so I have described to you two main methods to handle long input text. All of them needs to be chunking, to be chunked, but the difference is how you map or process and merge the summaries. Okay, now going back to our previous topic, what it's related to here is you need to be able to be careful of the context length that we are dealing with, right? So for writing a good application, what you know is actually, you know what the input text or the chunk size is. You know that. So this is known value. For the summary, the length of the summary, you can set it to a desirable number. Let's say you preset numPredict to 1,000 tokens. So by knowing this and knowing this, you can come up with a happy number for a buffer. Let's say a buffer is plus 50% or twice this. Then you can go back and set the Ollama setting to cover that, right? So this is a way out. At least for myself, my application is going to be doing it this way. So I know how many tokens I need to process, roughly the chunk size, and then I preset this, and therefore I can preset the buffer. That's it. That's what I will do in my coding demo. All right. Now, this is another repo called load summarize change. It's on Keston. You can go and git clone and do whatever you want with it. And we are going to actually take a look at it now. All right, load summarize. Here we go. Let me close that. There are many notebooks here, but I am going to do it in sequence. And the sequence is going to be map reduce, then refine, and then compare them. All right. I think Ollama is run here, so I would just terminate that and do Ollama serve here again. So I am going to clear everything. So I am at MapReduce notebook just to show you how things work here. All right, you load everything as usual, import. Now, as you see, there are, where is it? Okay, let me just do that for a quick reference. As you see that there are two steps here. There are two prompt templates associated with it. The map prompt template and the reduce or the combined prompt template, which is here. The map template text, write a detailed summary of this text section in bullet points. Use dash for bullet points and answer only the text, bullet points, sorry, and text here in summary. And that's the template with a placeholder that we need to fill in. Now, combined text template or is actually a reduce step is going to be like this. Combine these summaries into a final summary in bullet points, blah, blah, blah. And this is something that we, all the summaries will be pushed in and you ask for a final summary. All right, so you have your prompt templates here. Now I am going to load up the sample text. Again, the sample text is really long. That's like 200 something thousand letters in it. It's a conversation between Andrej Karpathy and his YouTube host. Anyway, so yep, that's really long text. Same helper function, one for splitting and one for counting tokens. So same as before, I am going to only focus myself to the first 50,000 letters. But now the chunk size is 500 chunk size. Small, very small. Okay. What I am going to do is I'm going to run this code. And with this chunk size, 500 chunk size, I will have 20 number of chunks. And you can take a look at here. Character per chunk, tokens per chunk, like roughly 500, right? Okay, now it's time for defining my LLM. So I have the context length, the chunk size is 500. So the context length of this should be enough. Maybe I should increase this. Did I increase it later? Hang on. Okay, let me just increase it now to 256 because we saw previously that 128 might not be enough, right? Okay, so let me run this, and it's going to take a while. Oops, nope, it hasn't run yet. Okay, so model defined it here. Okay, we only define a model here with the context length being around 1,000, and number of predict is only 256. And I'm curious, why didn't I do? Let me just put it there to 128, back as it was before. So in this code, we are going to use a wrapper from LangChain itself. It's called a function called load summarize chain. So we need to specify the chain type. In this case, a map reduce. And we are going to provide a map and combine prompt templates to it. Okay. That's the way to do it, and we put everything in there, and we are going to use only the first 12 of the splitting docket, split docs. Just to remind myself that we have 20 split docs in total, but I am going to run only 12 of them. Okay, are we ready? Okay, I have my terminal right here. So I am going to run. Here we go. Okay. No truncation. Fine. 1, 2 down. 3. No truncation so far. No truncation because the context length is 1,000 and the chunk size is only 500. So it's fine. It's very, very small, right? Okay. Okay. I don't know how many now. Okay. Almost done. Almost done. And the context, sorry, the number of prediction, we set it to, let's say, roughly say like 100, right? Okay. Now everything. So this code run is finished. What I want you to focus here is that it's going to start summarizing the map step, right? And there are going to be 12 steps here. This is the first chunk, no problem, no truncation. Second, third, blah, 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 until this one. And when it's doing the final generation, it hits this guy. What's the problem? The problem is that we process 12 documents, and let's say each document we process 12 chunks, and we collect the summaries. We are going to have 12 summaries, and let's say each summary is about 100 tokens long. 12 summaries, 100 tokens per summary. In total is 100 and 1,000. It's in total it's 1,200 tokens already, and it's actually larger than our token length, and that will get yelled at here. The final prompt, which is in this step, reduce all of these summaries. The final prompt comes to be around 1,500 tokens, where the context length that we set for Ollama is only 1,000. So we get ourselves truncated here. So all in all, what I want to show you here is a case where you run load summarize chain naively. You have eventually you end up with too many chunks with too many tokens that eventually overflow your LLM. The glitch here is that this code only using one LLM. It uses that LLM here and also there, right? If it has a flexibility mechanism to adjust the context length somehow, or allows two LLM definitions to be in there, this is fine. This is going to be able, we can handle this case. All right, that's my point. If you run it naively, you can run into this problem. Okay. Yeah, the output from load summarize chains can also give you the input documents. We have 12 of them, and the final output text, and you can actually see that it looks weird. It's not even finished here, right? Okay. So when I was saying that the way I will, at least personally, try to manage the situation, excuse me, if I do this manually, is I know my the chunk size, so I should know this roughly. I can set this guy so I know maximum value, and then I can provide a buffer so that I can set the context length of my Ollama setting properly. And this is how to do so. Yep, that's just a simple math here. The context length of the whole page. Actually, well, we don't need to talk about this. Yeah, this is, by the way, the context length of the whole transcription. If I want the context length of the chunk, this is my language. The other language is chunk size, and this is num predict. And you split the text, you get how many docs in there. So basically, with this much chunk size, I will get 13 chunks, and in total, I'm looking at words as much as 1,600 tokens for where is it? For this guy. This can be as large as 1,600 tokens. So yeah, math will help you here. Okay. Excuse me. I don't think I have anything to say here. Okay, manual process. I can do manual thing. because I want to show you that if you use two different LLMs at these two steps, you can handle this problem. So for now, I am going to, what I'm doing here is I'm calculating a full prompt for my first chunk, right? As before, is this guy. Okay, full prompt, first chunk, and I will run this. I will definitely get a summary for this chunk. This LLM has a context length, Ollama context length of 1000 tokens, and the number of prediction to be 256. Okay, and this is the response, the summary for chunk number 1. Look at how many tokens that is. Only 130. It doesn't actually use all of it. It would just stop when it thinks it should finish, and somehow it's finished at around like 130 tokens. Now, okay, what I will do next is to actually calculate a full prompt for all the chunks, for all the split document. I will then keep summary in this list. I'm doing it manually. I have 13 chunks here. I am going to get the summaries for all of the chunks. It will take a while, okay? And I will make sure, I think with the number of predict of 256 tokens, my summaries for each chunk is not going to be truncated. Okay, you can check out, check your Ollama run here. It doesn't seem like it has truncation problem. It should be fine. Okay. Using 12, right. Sorry. Yeah, it's about done in a few seconds, and voila, that's finished. So these are token counts for all of my summaries. You see like 100-ish tokens for 13 chunks. So roughly we are looking at 1300 tokens. Now for the last step, what I needed to do is to, I would join all these summaries together using the, what is it called? New line. Okay. If you're just curious what it looks like, all of these summaries for all the chunks get concatenated in this manner, right? And apparently there are now wow, that's a lot, 2,000-ish tokens. Okay. What I will do here is I will actually craft my full prompt, and the full prompt is going to be that's long, but pretty print the full prompt for you guys to see. Oops. Here, this is the full prompt of the refine step, and it says combine these summaries into a final summary in bullet points. Use dash for bullet points and answer only the bullet point text. And these are the combined summaries that we did before, a very, very long one. And then finally we have final summary. Okay, and this final prompt is 3,000-ish long. Okay, so what I can do here, and this is the trick that I will use later, I will define steps that I want the LLM to take. The LLM definition can take 1,000, 2,000, 3,000, and so on until it close to its maximum token limit. And this line is going to pick the next largest tokens compared to token count, the count of my final text, plus the number prediction. Pretty much I am exercising this I count how many tokens I have here. I know my numPredict set. I am going to set buffer by using a method that is just set the one that is larger, right, in multiples of 1000. Okay, so if I run this guy, what happens to be the next larger one is 4000, around 4100 tokens. And is it right? Yeah, you know, my full prompt is 3000-ish, so the context length of around 4000 is fine. So with that, I defined another LLM, right? LLM combined. I'm not using the same one as the map stage because I have my own new context length I want to use. So I trigger that, let it run. You see, there's no truncation problem. Everything is properly set. And I have my answer. Here we go. And this is the reduced or combined answer. And you can visualize it here. This is the manual one, and it seems to be complete. Right. This is how you do it manually. Okay. Now for this one, for this notebook, I'm just wrapping everything that we just discussed before, throwing away something that I don't want, which is the naive use of load summarize chain. So load, we have map and combine prompt templates here. I moved everything related to configurations of an application over here. Model, base, chunk size, overlap temperature, number of predict for the map, okay? Number of predict, like, oh my god, like how long can this guy be maximum? It can be different from this. So right now I set the max to be, wow, quite long. 512 for this, and 2000 for this. See, when you use different LLMs, you can go crazy with customizing this. All right. Oops, I forgot to run that part. Well, let me just clear, restart, and run. Okay, I think I clicked ran all now, but anyway, helper functions right here. I packed the select next context size to this function. I prepared a document. Sorry. This is just to, if I have a raw text, Python text, I am going to chop it into split docs with this. Okay. And this is the whole thing. A run function takes a transcript, split it into chunks, get the maximum, get the suitable number of context length from this function, because I know this, right? I know the prediction and I know the chunk size. Again, applying this method here, then I will do a map. This is LLM for the map section, and then I map all the chunks, and then in my second phase, the reduce or the combine phase, I craft a new LLM. I choose an appropriate context length with this. I count and the numPredict. And this can guarantee that you are not going to run into a problem of being truncated at the last stage here. Okay? The sad thing is, if you compile this into if you're still using the load summarize chain of a very long raw input text, you are likely to run into a truncation problem. But if you don't look at Ollama serve the printout, you might not know that your truncation, you have a truncation problem. And that's a problem, guys. All right, right now I run this code. It's just doing its thing now. It's mapping like 22 documents. Just a few chunks to go. So I am going to open up a refine process, because refine process is very, very easy. Is it done yet? All right, last chunk for the mapping process. Now, in a few seconds, it's going to define a full prompt for a combined stage, count how many tokens the input prompt is, and select a larger context size from this, and then run that command. And here we go, it's done. This is done, and then if we print it, is like this. It's actually pretty detailed, isn't it? Yeah. Okay. That's the map reduce. Everything combined together in a manual way. And this is going to be transferred to a code that I will show for a YouTube summarizer repo. But before that, we still have to go through the refine notebook. Now, remind ourselves again what the refine method is. You are going to split two chunks as you will normally do. But for chunk number one, you get the summary and you set it as a existing summary. And then you process next chunk for its summary. And then you ask the model to, all right, you have existing sum and a new sum. Refine them into a new existing sum. All right, this is a process. And apparently, if you set your Ollama, context window large enough, this can be run with just one model. Let's say that your chunk is usually your chunk is whatever it is, because what I'm curious here is this can be long, right? So let's say this is 100 or 200 tokens. This can be usually the model is not going to output, it's not going to write something for long. And from what I've seen, at least in Ollama settings, this is like a few hundreds. Let's say 500 max. This is another 500 because it's the output, right? 500 here, 500 there. Let's say 500 here. So everything here, it's likely to be less than 2,000 tokens. 2,000 tokens. So if you decided that your chunk size is 4,000 for some reason, so if you set your Ollama to be 4,000, then for that it covers everything. So for the refined method, it's extremely simple in terms of setting the Ollama context length. But let's go through the code convention anyway. When you want to use the refine method, you can customize your prompts, but it's going to be different from the map reduce. You have two prompts. The first prompt is just going to be used in this summary. So it's the same prompt in this step and that step. So this is just the summarize this chunk for me prompt, like this, right? Write a summary of the chunk for me. Then the next prompt is going to be this step, the refine step. You are going to have, you say that AI, you get two text. The first one is context existing answer. The second one is the new information. You need to combine them. This is the refine step. Okay. Okay, I run that. Load the transcript as usual. Same user helper function. Prepare documents. So now the chunk size is that. chunk size is 1000. Okay, so I am going to have 10 documents. So here we go. Yeah, look at that. If now the chunk size is 1000, and if I set the context length to be 2000 for Ollama, and the num predict is 256 for existing summary, and 256 for the num, the new summary. Let's say it's 500. It's not going to exceed 2000. So in this case, most of the time you are going to be okay with just one LLM, and that's why most likely if you use refine method, you are not going to be doing it manually. You can just use the load summarize chain. But for the load summarize chain, make sure you specify the chain type like so with the refine keyword, and you need to input this. You need to use refine prompt equal to and question prompt equal to in order to do that. All right, just well, I have 10 only, so just for the sake of everything, so just run the whole thing, and look at that. Look at Ollama return. So it's processing 1. Now it's going to do a summary. So how many calls that you need to do? If you have 10 chunks, you need to have 20 calls. On the contrary, if you have 10 chunks, you are going to use 11 calls. So on the larger side, MapReduce is cheaper compared to the refine method by twice the LLM calls, right? Yep, that's why it's slow too, in sequence and also many LLM calls. Okay. Oh, might take a long time to do this. Okay, while it's running itself, I would just show you the wrap. A wrap is packing everything so that I can transport it to the actual YouTube summarizer repo. Again, import the two major prompt templates here. Move configuration over here. Helper functions, prepare documents, and in the run section, it's just as simple as calling the load summarize chain. But again, as to apply my ideas here, the idea is again to create a buffer, right? So the chunk size, what I'm worried is the number of predict and the chunk size, and I don't know the good buffer number, so I just double it. I don't have a good reason for that, guys, sorry about that. But if I have to defend my choice here, chunk size, right? We know chunk size, and we know this guy, and usually the chunk size is larger than the summary. Otherwise, it's not a summary, it's going to be an expansion, right? So typically this guy is considerably larger than this. 10,000 tokens down to, sorry, 1,000 tokens down to 100 tokens, so 10x. So what I say, maybe there's a better way, but I would say add this to that and multiply by 2 should be a safe zone. So that's what I did here. I need to remove that, but anyway, so this should be a safe zone for me to do, and I would just call the load summarize chain as usual. And yeah, I'm not going to run this because it will take time. Go back to the refine notebook. Everything is done now, I suppose. Yep, with the check mark there. All right, so, and this is the text output from the refine method. Roughly the same thing, right? Could be the same quality here and there, But yeah, this is how you do refine method. So I have generated pre-generated results from running this. If you see here, oops. If you see here at the bottom, I have exported to a file because I want to compare it side by side between the two methods, right? Map reduce manual, it had something like this, and the refined one is on the right hand side here. To be honest, I actually prefer this one. If I read it through the actual transcript itself, it's actually more like this one, more like the map reduce than the refined method. But I didn't do a rigorous reading, so I could be wrong. They could be roughly at the same performance. Okay. All right. So now we have done everything we needed to do to understand summarization. You now know that you need to chunk it, and then you have two approaches to handle the chunks that you now have at hand, right? And in terms of the actual implementation, you have liberty to set a buffer because you will know the chunk size, input chunk size roughly, and you can predetermine the number of prediction you want from Ollama, and therefore you should be able to define your own buffer and get that problem off your hand. With everything combined, I rewrite my own repo on a YouTube summarizer. So this notebook is also available for you, but yeah, this is the actual page for that. We made a where did it go? We made a user interface now that is much better than before. Before was just very simple, but now this YouTube summarizer has options for you to choose whether you want to use map reduce or refine method, and map reduce also provide you with a menu option and a load summarize chain option. Additionally, you don't necessarily need to give your YouTube link and pull in transcripts anymore. You can copy any text from anywhere into oh my god, come on, into the transcript section and summarize. So open up more possibility of usage here. So let's take a look at the code. The code is quite significantly changed. Not this part. Import is the same. This section is keeping the preset template for the map step, the reduce or combine step. These guys are for map reduce method. Now for these guys, the questions step or the summarize step and the refine steps, these guys are for refined method. You put it there, it's going to load up when your application loaded with Gradio. Configurations now set as global because we want to update when user change the values inside the user interface. This one is still the same thing. Grab YouTube video. This is extract video ID to help grabbing the right YouTube video and transcript. Text splitter you've seen before. Convert text to token seen before. We just want to count how many tokens there are. Get larger context size. Again, this is you've seen before. It's my way to just use the one step up by like 1,024 tokens, right? for the context length. Now, get YouTube transcript is the same. Get LLM is the same as before. Convert text to split. So this is a helper function you've seen before. Raw text Python string got chopped up into chunks or split docs, ready for processing. Okay. Now there will be 3 buttons for each summarization approaches. There are 3 summarization approaches. The first one is map reduce with LangChain, load summarize chain. The second one is map reduce manual that we did before. And the last one is refine with LangChain, load summarize chain. So I made 3 more functions that will be triggered when respective buttons get clicked. So this one is going to load up from the config, global config. We will get the input text got chopped up to chunks properly. Get the right token using the get larger context size step up as before. Define my LLM, prompt, map prompt, combine prompt, load summarize chain for this one. This one is the map reduce LangChain, right? For the map reduce manual, we will do what we did before, but manually. So yeah, each summary got calculated, okay? And eventually we're entering the combine phase where we compute the final prompt, pick the appropriate buffer to define the Ollama context length window and the compute, right? Lastly, refine with LangChain normal as normal before. We eventually will call load summarize chain with chain type to be refined, okay? And these functions are used to update configuration settings values, right, up to the end of here. This is for conveniently load up summary sample text for you to play with. And this is just Gradio, right? Gradio, event registration and clear. Okay, so self-explanatory to some degree, and I think we are ready to launch. Poetry run Python main.py. All right, so this one. Okay, here we go. As I mentioned, you can provide a given video link and load it, get information. This is not going to load a transcript yet, but you can click get transcript if you're happy with what you see here, and the transcript will be pulled in, right? And right. Yep, this is based on this video. Sorry, yeah, this YouTube video is my video, and it has about 700 token count. That is quite small. So in this tab, you are here. Now we are going to go to the next tab, the Summarize tab. This is going to be a section where you specify model parameter. In the future, you might have more more models in your Ollama model, but you need to go into the code and change it, because now I hard code it, because yeah, this is what I want to use. I hard code it for now. You can change this, or you can change the temperature, let's say, to that value, whatever it is. Now, text splitting parameters. This is the chunk size we're talking about. So right now we have 700 chunk size, so we can say, well, that's too small, so just it's fine. Just leave it for now. All right, now approaches, you have 3 tabs corresponding to each method. So for the reduce LangChain, map reduce LangChain method, we only have one parameter to use, which is the number of tokens to predict. Just to remind you, we will adjust. Why is it? We still use this trick. We adjust the Ollama num CTX with the buffer size. Okay, that's why we only need to provide this, because we know the chunk size and we know this, so we can fix the context length. Now you have a chance to customize your prompt for each of the steps here. This is the mapping step, and this is the combine or reduce step. Okay, you can improve upon me by having a save button and save it to some disk, because right now if you change something and you quit your app and you reload it, the preset, your change is gone, the preset is going to be loaded back like this. Okay, you can improve upon my my code. Anyway, so if I'm happy, I can click this one and the result will be populated in the text box below. Now everything under the tab here belongs to that tab. You can move into another section and configure whatever you want and click summarize again. Okay, yep, this is done. The other used Gemini. This is a while back in May, I think, and this is, I remember what the content is, so it's actually pretty good. All right. For the map reduce manual method, you have two number of predictions to specify. Number of prediction at map settings, usually small, and the refine step, it can be large. Okay, because now you're combining many things, many summaries, and the final summary can be long, so leave an opportunity there. Okay, and lastly, with the refine method, you have only one, the same one as this guy. This one is the number of prediction. You can also customize your prompt for each of step here. Okay, so let me just load this up again. This is a sample text that we had before. It's Andy Kripathi having a YouTube video with a host, in total of 3 hours, and this one is about 43,000 tokens long. It's huge. So what we have to do here is, I'm not sure how long it's going to take to do that, to summarize the whole thing, but let's say I want to do 4,000 tokens, so that will give me around 11 documents, right? Chunk size, and I want to do, yeah, this is tricky, but I want to do this one first, and before doing that, I'm just going to kill this. I am going to bring back, okay. Oh, okay, it's in used. Where is it used in? This guy. Oh wait, did I just kill the process? Oh yeah, I just killed the Gradio, so I just need to redo it again. Alright, now refresh. I'm going to load sample text again. Yep, 43,000, and let's say this is 0.5 as before. If I do 2,500, okay, let's try. Let's see, 2.4. Yeah, I think it's going to take too long. Anyway, let's do it. Boom. So 25,000 tokens. Okay, so we have, let's say, 45,000 divided by That's about 18 chunks, give and take. Just 2 chunks now. Damn. It's going to take a long time. What I want to give you, but maybe cannot show it here because it's being run here, is that let me go to this page. All right, so you see this detailed summary, right? The detailed summary is, yeah, it's going to give me some result better than concise summary, but the detailed summary is not specific enough, right? The principle of writing prompts, a good prompt, is to be specific and clear. Detailed summary is not specific enough. If you want, and I think this is the cause of when we see that no matter how many number of predictions we specify, be it 256 or 512 or 1024, what we saw earlier, most of the responses are stuck at around like 200 tokens. This could be because we are not specific enough in our prompt here. I did try it early on, but unfortunately I closed that run before. I said that a summary of detail should be 5 to 10 bullet points, and that's actually going to drag, force the LLM to use more tokens, and eventually going to give you better or lead to a better detail, especially when we are going to deal with a very, very long context input like this. Because I think if you have time to wait for this guy to finish running, you will see that the summary is way too short for the length of this input text. For the benefit, let me just run something in parallel off my computer, which is Gemini 4, not Gemini, GPT-4o mini. Okay. So if what I'm trying to do here is actually where is it now? I am going to copy this text, just this one, okay, just this one into this one, and this one into here. Okay, yep, that's, oh, look at that. Haven't seen this before. Message is too long. Wow. All right, that's where maybe where the Gemini shine, because Google boasted that its model can support up to 1 million tokens. So let's see. Oh God, it can't. Look at that. It sucks. Yep, it cannot finish it. Wow, I can't type. So basically, inputting to ChatGPT or Gemini with a very, very long text doesn't work on its user interface. Okay, what do I do? Maybe I should use this one. Oh, right. Okay. Where is it? Actually, I have run that before. This is actually the output when I give everything to OpenAI GPT-4o mini via the API, and this is the result it gets me. Okay, we might be able to compare that to the result of this run, but this run is not of this run. Oh, it has finished. Wow. But I doubt that it has actually finished at all, because look at that dangling stuff. What is the problem? Okay, let me actually try to see here. I think the problem is that the context length is too short. I'm sorry, the number of predict token is too short. Okay. Yeah, it can possibly be that. Alright. That's unfortunate. But I think it's coming in the right direction. Sadly, we have to run again for being safe. And it's going to take longer, because the longer context length, the more time it needs to process. Okay. Ollama run. Well. Okay. This is going to be a little bit boring when we are waiting for this guy to finish processing everything. So what I can show you guys is the summaries of everything. Okay, just to recap everything technically, because I know this is a long session. Ollama, you need to be careful about the context length, because you might run into a situation where you don't realize that your input prompt is longer than the default setting of the Ollama context window here. And you can adjust that by using this parameter, num_ctx. Another parameter that you need to spend your time checking out is a number of prediction, num_predict. And this is going to be how many tokens the model, the Ollama will ask the model to produce before it stops it, right? So if this number is too short, then your answer can be incomplete. And we've seen that before, that it just stops and returns, okay? And ultimately, you are limited by the LLM's intrinsic context length, and that depends on what models are using. But most of the time, right now, the minimum context length that people support is around 128,000 tokens. Okay. Challenges that you will find because of these two configurations is that sometimes your context, the input length is longer than the Ollama context length settings, and sometimes your num_predict is too short, so your answer got cut off. And another application that are related to the topics of context length, if you implement it with Ollama, is the summarization problem, right? Usually, sometimes, well, not usually, some input text can be too long. And the way to handle this is going to be always cutting into chunk, right? And then you are facing with a problem that how are you going to process the chunks? You can process it by MapReduce method, and this method can run summaries for chunks in parallel and then follow up with one last step to combine everything, right? But this is risky because you need to concatenate all the summaries in sequence in one prompt. This will present a challenge, a potential challenge to exceed the context length of Ollama setting again. Okay. But because this one can be run in parallel, because they are not dependent on any others, so this process is fast, can be parallelized. The second method is refined method. You know, you need to run things in sequence. You run the first chunk, get the summary, and then you run the second chunk, and then you for each of the next chunk you combine, you process, you ask the model to refine, come up with a new existing summary. And this is forced to be in sequence only. So this is slow, but you are unlikely to run into a problem of the prompt for Ollama being too long. Okay. But my recommended way to handling to handle Ollama context length is by exploit the nature of what we know and what we don't know. What we know is usually the chunk size. We know that, and we need to specify the number of prediction anyway. So this is what we know, and therefore we can provide some buffer, and therefore a definition, a good number for Ollama context length window. Yep, and that's pretty much everything packed together, right? And hopefully this guy is finished. Is it finished? Hard to say because it hasn't been. Oh, it has finished, guys. Look at that. The last one is a full stop, and this is the result of expanding the number of prediction to be almost 3,000, not almost 3,000 tokens each. Wow. And I'm sure this is repetitive somehow. This is way too many. It could be true. From a quick look, it actually is okay. But you know, this is, to me right now, this is not a final step yet. This is raw, some kind of raw. You need to massage it a little bit more. Look at that, like the speaker suggests that, blah blah blah. The speaker think. I want to summarize into topics, right? So this is just the first step. Okay, you can add more nodes, right? And then if you do, that nodes can be summarizer, you know, the editor, and then you can expand. Therefore, you can expand this repo to be an agentic workflow. Okay, and usually, if you have a very long text, you definitely need lots of agents. It's better to have more than one agent to do the summarization, because they can help each other. Okay, and that's pretty much it, guys. So we have seen a lot today. We update ourselves by knowing about what Gemini 2.0 is from Google. We covered announcements from OpenAI, the 12 Days of Shipmas. And for the technical part, we went through hardcore stuff like Ollama context length, LangChain summarization, methods, map reduce, refine, and using the load summarize chains, or come up with your own map reduce manually. And lastly, packing everything into a nicely user interface YouTube summarizer. So that's everything today. So before we depart, don't forget to subscribe. Click subscribe here. Case done by AI. We're on YouTube, LinkedIn, Facebook, X, and Substack. So for today, I know it's a long day, but thank you so much for staying with me, and we'll see you next time.